So we have already heard a lot about the cognitive aspect of Arista Wi-Fi. In this segment, we'll talk a little bit about another key element of our solution. That is basically the architecture is very open in the sense that we allow integrations with third-party systems. We allow customers to build their own applications using our APIs. And recently, we've been working on supporting OpenConfig, which essentially allows you to implement your own network management system from scratch. So Murthy will touch upon the third one. I'll quickly walk through a couple of points on the API front. So on the API perspective, the API allows you to develop applications to fulfill specific customer requirements. For example, somebody may want to build a new reporting tool or a new monitoring dashboard. APIs can also be used to automate complex tasks such as configuration management and network assurance testing. And finally, we could use APIs to integrate with external systems, for example, to support new user onboarding mechanisms or to integrate with third-party location-based services. So I'll quickly show a couple of examples of these use cases. So let's start with pTracer. So when the pandemic hit last year, some of our customers wanted a tool which can help them figure out what is the occupancy in their offices, where people are moving around, and who is in the proximity of these other users. So we built this application which can recreate the association journey of a user or a person of interest and identify who else was there in the proximity of this user during the same time interval. And the way we do it is that the application uses APIs to pull association logs from the cloud, and we analyze them to generate a set of reports, which basically traces the journey of each user in the network. So just to give a quick idea of what it looks like, so we show on the top left association record of a client, which essentially shows the APs that the client connected with over a 24-hour window and how much time the client spent at each AP. So that gives a sort of a journey of the client over a period of day. And below that, you see a chart which shows the number of proximal users for this person of interest, which is essentially people who are around this particular user at different points of time. And we also highlight, which users actually they were. So you can figure out if you want to trace the contacts, you can basically use this information to narrow down the list of people who you need to target. And on the right, you see a floor plan where on the map, we show the APs, which are shown as, dots. And the color of the dots represent the relative density of users around each AP. And the red dots basically show the areas where there are more users than is desired. So with this, you'll be able to, make your workplace more healthy. The second example is of an automation portal. So imagine deploying thousands of APs every week on a month-by-month basis. And doing this using the CloudVision Wi-Fi UI can take a lot of time because you have to manually create locations, you have to provision APs, and you have to apply the configurations. And this whole process is quite time-consuming. So our customer basically developed an application which uses Arista API to automate the entire process for rapid deployment of new sites. And this is a screenshot from this application where once the site is acquired by the business team, a work order is created for the deployment team, and then the entire sequence of steps, starting from the provisioning of the APs all the way to creating a SSID profile, is fully automated. So you can do a site deployment like in a matter of minutes instead of hours that used to take when it was being done manually. The last example I want to talk about is a voice-assisted network interface, or VANI. So VANI is an application which is developed for mobile devices through which a customer can essentially accomplish basic network monitoring and management tasks by using an interactive voice-based method. So I'll just show a quick demo of VANI, and hopefully that will give you an idea of how it works. So let's hope this works.
Top applications by traffic.
Do you mean get the top applications by traffic?
Yes.
Okay, for how many hours? Pick 2, 4, 8, 12 or 24 hours?
12.
Done.
So you can see that the output is in the form of which applications we used, how much data over the last 12 hours as requested by the user. So I'll stop here in the interest of time. I think we can take the questions later. I'll hand over to Murthy.
Hey, good afternoon, good evening. So I'll talk about OpenConfig in the next few minutes. We are running out of time, so I'll just breeze through this topic quickly, and then maybe we can take up any questions, in the breakout session. I think overall, I think like we look at OpenConfig as a way to extend our cognitive Wi-Fi in an open way, and like we are committed to OpenConfig. OpenConfig is big in Arista. All of our products have had support for this since some time now, and so does Wi-Fi. And we also see OpenConfig as a way to bring together the internal modules and products within Arista, be it streaming really granular data from our access points to our to the cloud, or bringing together wired and wireless data to build unified Cloud Vision dashboard. So I think with that, I'll probably jump into the problem statement and the use cases first. I'll talk about the OpenConfig interface that we have built into our access points. So essentially, can large enterprises and universities, can they build their own auto channel or auto power algorithms, right, that suit their specific needs? Can they get really granular raw Wi-Fi data, be it RF data, client data, application data, into their own collectors, and start looking at specific aspects of their networks? Can they build automated systems that they can use to respond to events in real time, those that are happening in their networks? I think OpenConfig is a great way to enable all of these use cases, because the most interesting aspect of OpenConfig, the really state-of-the-art and powerful streaming telemetry, enables all these use cases and at a really granular and advanced level. So I'll talk about our what we are doing in this area and the solution that we built. So we have built this solution in partnership with some of our enterprise customers. We went through a few iterations, taking feedback from them, fine-tuning the solution to the point where it's now in production. And what it does is it provides a way for our advanced users, those customers that have the capability and the bandwidth to actually look at their specific needs and maybe something which we may not have thought about yet, use this powerful open framework to fetch the data using streaming telemetry and build those applications on top of this. So that's the main use case we are talking about here. In terms of the architecture, so this slide captures our Cloud Vision Wi-Fi architecture in a nutshell. So it's a disaggregated distributed control plane. We have a very flexible data plane, and then the centralized management plane. So the new addition to this is the OpenConfig GNMI and GNOI interfaces that we built at the access points, using which our end users can actually build their own systems in the form of OpenConfig client, all the way from complete management solution to specific streaming specific telemetry, state leaves, etc., into their collectors and for specific use cases. And we have given some thought before putting this interface directly into the APIs. One of the key factors of OpenConfig is streaming telemetry. It's the most powerful aspect of OpenConfig, and we believe that having access directly to the APIs would ensure that there is no intermediate node that would introduce latencies and delays. It would scale better, and in fact, right now we are able to support 1 second frequency to stream data, be it like client RSSI or some counters, etc., with 1 second frequency directly from the API. So this architecture gives a lot of flexibility and scalability and power to the end users by eliminating any intermediate node. And in terms of the actual operation, we built 2 different modes. In one mode, so the OpenConfig can be enabled in 2 different modes. So in one mode, you can enable the full thing, both configuration and telemetry. So which means the entire set of sets, gets, and subscribe, all RPC calls are enabled at the API, and this end users can use to build both configuration and monitoring. At the same time, the Arista Cognitive Cloud Monitoring also works in parallel. So whatever is available on our cloud dashboard, all of that is still available. So they can look at the data, troubleshoot from there, as well as continue to build their own systems. The second mode of operation is streaming only, where configuration is still happening from our cloud and monitoring is also happening from our cloud, but they can stream specific state leaves, specific data, granular data using the powerful streaming telemetry into their own collectors, and then build additional visibility that that they need into their networks. So this is the second mode we support. And I think the last thing regarding the models that we support. So right now we fully support all the public models for Wi-Fi that are out there on GitHub. In all aspects, be it get, set, or subscribe for streaming telemetry. And in addition to those, we also have a lot of augments, certain functionality that is not yet part of the public models, which we have published the augmented models ourselves to enhance functionality and provide that same interface through OpenConfig. And so that is also, we publish these models on GitHub. And I think I would like to conclude this session by saying that, we also look at OpenConfig as a way to bring together our own internal systems, like components and systems. And, OpenConfig is like one of the foundational layers of, everything you have seen, be it cognitive Wi-Fi, unified wired wireless, and so on, because of its powerful streaming telemetry, etc. And that gives us advantage in terms of opening up the same interfaces to our, like in an open way to our customers and, the public in general.